Okay, so let's continue with this example. So we need to compare the heat of hydrogenation for this compound. Okay, so as you may notice that the end result of the after the hydrogenation is done for all the three compounds will get the same structure. So we can actually compare the heat of hydrogenation based on the stability of these compounds. So the stability of this compound is inversely proportional to the heat of hydrogenation released. Okay, so for comparing the stability, we don't need to compare on the resonance because none of the compounds here exhibits that. Just compare on the based of number of alpha hydrogens. So the number of alpha hydrogens here is 3 plus 3 plus 4, that is 10 alpha hydrogen. Here how many number of alpha hydrogen? 1 plus 3, 1 plus 2 3, and here 2 plus 3 plus 1, 2 plus 3 plus 1, 6 alpha hydrogen. Hence this is the most stable, hence this would have the least heat of hydrogenation. Next comes second, next comes first, next comes first, next comes seconds. Oh, am I right? I don't think so. So this should not be heat of hydrogenation would be most for first, then third, then first. Okay, now let's look at another example. We have this one, and this one. Now let's compare the heat of hydrogenation just based on the number of hyperconjugating structures or the number of alpha hydrogens. How many alpha hydrogens are here? 9. Here 3 plus 2, 3 plus 2 is 5. Here it's only 2 or 1 rather. So heat of hydrogenation would be the order of 3, 2 and 1. And next let's compare for this case. This one and this one. As the end result would be the same, just calculate the number of alpha hydrogen. For calculating the stability, reverse that for the heat of hydrogenation. Simple as that. So 3 plus 2 plus 2, 3 plus 2 plus 2 is 7, and here 3 plus 2 plus 2 is 4. Obviously second is more having heat of hydrogenation than first one. Okay, now let us compare why I'm not drawing any double bonds. Are all these compounds same? No, just drawing it. And finally this one. So if you see, all the compounds will result into the same compound, hence we can compare the heat of hydrogenation based on the stability of all these compounds. So let us calculate the stability. So this compound and this compound are already in the resonance, so the first and the fourth one would be the last in the heat of hydrogenation. And let's compare the number of alpha hydrogens. This is having 1 plus 2 3 alpha hydrogen, and this compound is having 3 here, 3, and again 2 plus 2 7. So obviously fourth would be the most stable, so least releasing heat of hydrogenation than rest of the remaining compounds. Now let us compare between the remaining. So how many double bonds or alpha hydrogen is there in this compound? 4. How many for this? 3 plus 2, 3 plus 2 5. And how many for this? 2 plus 1 3. Hence third, then obviously fifth, then first. So this would be the order. Okay, so sorry, this will be 2 rather. Just a second, actually we calculated something wrong here. Let me redraw it. So the structure actually was not clear to me as well, so sorry you guys for the same. The structure is something like this. Okay, now let's calculate the number of alpha hydrogen for this compound. Number of alpha hydrogen would be 2 plus 2 plus 3, it will be 7 alpha hydrogen. Okay, and this is actually having 4 only, so let us rearrange something here. So 2 is more than which one? 2, 3, 4, 5. So 2 would be more than 5, which would be more than 3. Is this the case? No. The now correct case would be 2 is more than 5, which is more than 3. Okay, so let's move on to the next example. Here we have okay, so let's calculate the alpha hydrogen only, because we don't have any other resonating structure possible to calculate the heat of hydrogenation, the order of calculation of heat of hydrogen. So this is having 2 alpha hydrogen, this is having what? This is having 5 alpha hydrogen, why 3 here, 2 here. This is having 4 alpha hydrogen, why 2 here, 2 here. So the amount of heat released would be of the order 1, 3 and 2. Okay, so just a thing that came to my mind, that just a note, this is not related to the heat of hydrogenation. It may or may not be related to the heat of hydrogenation, but on the relative stability order, we should remember that the stability of paraxylene is more than metaxylene is more than paraxylene. Okay, so stability of metaxylene, this is called xylene structure. The phenyl ring substituted with 2 CS3 groups, and this is called paraxylene. So this relative order, the relative stability is more in this case than in this case. So this is just an experimentally verified fact, so you can just remember it. As you can see that obviously the number of resonating structures and everything is same in both the structures, number of hyperconjugating structures, resonance structures. So what is remaining to compare is the inductive effects of the both. So as you can see that for the inductive effect, this is having more inductive effect on the phenyl ring than this one. Okay, so this is more stable than paraxylene. Okay, so this completes this lecture, and from the next lecture we'll be taking on heat of combustion.